we are going to talk about IP vulnerabilities. There is a number of vulnerabilities that target the internet protocol. Now remember, the internet protocol operates there at layer 3. The internet layer or the network layer, if we are talking OSI, and these vulnerabilities vary. We are going to take a look at each one of these. We have the man in the middle attack, we have session hijacking, we have IP address spoofing, we have DOS attacks or denial of service, we have distributed denial of service attack, the Smurf attack, and resource exhaustion. Let's go ahead and take a look at that first one, a man in the middle attack, and see how it targets IP. A man in the middle attack is the type of attack where somebody who is malicious inserts themselves into the middle of a conversation between two systems. So imagine you have A and you have B and they're talking to each other, and then all of a sudden C ends up right in the middle of this conversation, and all of your traffic start to move rather than directly between A and B. Your traffic start moving through C. C has inserted himself into the middle of that conversation. A doesn't know it and B doesn't know it. Now, how bad can this be? Well, it can be really bad. So this is an eavesdropping type of attack that exploits the real-time traffic, right? So A and B are having this conversation, traffic's flowing back and forth. C gets in the middle of that conversation and start to capture that traffic. The end-to-end connectivity is broken. A and B don't know it, and C is able to start capturing all of the traffic. Now, what kind of thing could happen here? Well, okay, let's say that A and B are trying to set up maybe some encryption, and they are going to exchange their key. So A says, all right, send me your key, and then B sends the key. Boom. Okay, so now what happened? See, right there in the middle now has a copy of that key. So using that key, we encrypt some traffic. So all of a sudden you have got encrypted traffic that is coming across, and normally the traffic parties A and B would be the only ones that can read that encrypted traffic. Well, C grabs that traffic and changes it and decrypt it. Read that traffic. Let's say that it is a transaction involving money. Let's say that transaction is sending money to a specific account. Well, that attacker that has placed himself in the middle of the session can now change the destination account number where those funds are going. So there is a lot of people that are susceptible to attack like this. It could be financial institution, that is one example. The example here of changing the direction of money, sending money to a different account, but it could also be anybody that want to sit in the middle and capture traffic, perhaps to replay it and see what you are doing. If they want to replay conversation, maybe you are doing messaging, maybe you are transferring file and want to capture those files. Maybe it is intellectual property that is very important to their organizations. Now this is a form of eavesdropping, as I mentioned, and it is just one example of man in the middle attack. There are other forms of session hijacking, man in the middle type of attack. We actually are going to talk specifically about session hijacking. But understand that session hijacking is yet another form of a man in the middle attack. But it could be an attack known as hijacking. This attack would be sniffing packet to steal your session cookie and then using those cookies to get encrypted login information, even in the situation where a website might be secure. There is also a session hijacking method called even twin, and this deals with a Wi-Fi network that appeared to be a legitimate network. In fact, people put a Wi-Fi pineapple in their backpack and then walk around advertising AT&T wireless. And what happened? Well, some of your phones are set up to automatically connect to these networks, and then all of a sudden they are able to intercept data. And of course, sniffing attacks where somebody is intercepting your traffic. using an application or some type of software to view what is going on. Again, there are just some example of session hijacking as well as man-in-the-middle attacks, both vulnerabilities that are targeting the IP protocol. Now, how does this happen? Let's just look at it for a moment from the IP level. What is inside of an IP header? Remember, the IP header has a source IP, a destination IP, and a protocol. These are going to be the important parts, right? Protocols tells me if it is TCP or UDP, and the source and destination IP have to do with the routing of my traffic. Okay, so we are dealing specifically with the internet protocol. How can something change my path between A and B? How can that session get hijacked? How can a man-in-the-middle attack ensue? Well, very simply, we can have that attacker, which we said was C. The attacker can change either the source or the destination IP. So if there is a way that they can capture packet, they can make themselves appear to be someone else or just simply place themselves passively in the path, well, then they are able to capture that traffic. But again, we are talking specific about the internet protocol vulnerabilities. So if we are going to hijack a session, we are going to be modifying either the source or the destination IP, or perhaps both. Now this could go up a layer, right? It go into the DNS resolution. If DNS is resolving the wrong website, then you have somebody who could be sitting right in the middle there. That is one example. Let's take a look at another example of a vulnerability that attacked the internet protocol. How about IP address spoofing? Alright, so how do we do this? In fact, there is more involved in IP address spoofing than just layer 3, just the internet layer of that TCP/IP stack. And that is regardless of whether it is a man-in-the-middle attack or session hijacking attack. Again, let's just talk about IP address spoofing. So we have A, and A has an IP address of 10.1.1.10, and their default gateway is 10.0.1.1. Okay, so the gateway is a router. Remember, gateways are router. They are layer 3 devices. This is all kind of knowledge that you should have already, right? Understanding basic knowledge, basic Cisco, iOS, that kind of things. So A is our PC. A is one switch network. So there is a layer 2 device in here. And then there is a Cisco router on the network. That router is the gateway. Now, how does normal routing work? Whenever A want to send something to someone off the network, well, there is a couple of things that happen first of all. So the first thing that A does is to look to see if it is on network or off network. And if it is off network, then the second thing it does is it look for auto resolution for the default gateway. And then it is going to forward the packet to the default gateway. Let's back up a step. The first step, whether or not we are on network, how is that happen? Well, we have to resolve a name first of all. So let's say I want to get to cisco.com, we are going to use. Do you remember the protocol DNS to resolve an IP address for cisco.com? So let's say that the IP address comes back and the address happened to be something like 192. I'm just going to use a private IP address space here, 192.168.1.100. Okay, so now A will do a logical, and between its own address, the 10.0.1.10 and the 192.168.1.100 address, and that determines that these bits don't match up, we are not on the same network, so I have to send it to my gateway. The gateway has been configured already. Generally, two ways that is going to happen. That could have been done through static assignment, or that could have been done through DHCP, which is probably more common. So you have gotten a DHCP address, you have gotten a gateway, you have gotten your DNS, all that stuff come from the DHCP server. And so now you decide to forward this to your default gateway. But before you can form that Ethernet frame as you pass it down the protocol stack, remember that encapsulation process. Before you can put your layer 2 header information on or your link layer header, you need to do an ARP and you need to find the MAC address of the default gateway. Okay, so you ARP, you get the gateway address. So let's just assume that in this case the default gateway address is 0001.0001.0001. We are just making an address up here for simplicity's sake. Okay, so now you have got ARP resolution, and that ARP resolution say 10.0.1.1. My default gateway is the MAC address that we just talked about. Okay, so now you can forward this over to your gateway. Your gateway is going to get it, and the gateway is going to forward that packet onto another destination, right? To the next hop router based on its routing table, and it is going to move that traffic through the internet. Okay, so that's what we want. We are trying to get to 192.168.1.100, which for our example purpose is cisco.com. All right, now we have an attacker come onto the scene, and to the attacker is plugged into our switch network, and the attacker, this black hat guy here, he has a MAC address of 0002.0002.0002. What he is going to do is he is going to start to spoof an address. So he sends out gratuitous ARP. This is an ARP before anybody asks for an ARP that say, "Hi everybody, I just want to let you know that I 002.0002.002 I am 10.0.1.1. He's lying to everybody and saying he is the default gateway. He just started spoofing the gateway's address. He is saying, I am the gateway, send traffic to me. So boom, traffic goes to him as the default gateway. Well, he knows where the general gateway is, and he forward traffic to it. And now all of a sudden, not only do we have an IP address spoofing attack, but at the same time we have a session hijacking attack, because he is right in the middle. Oh, and don't forget, yes, that is a man in the middle attack as well. He is sitting right in the middle, capturing all of traffic. This concept of IP address spoofing, pretending to be someone that is you are not, this leads us to another type of attack that make use of IP address spoofing, and that is denial of service attack. So one common denial of service attack utilize all of the resources in sending a send message and spoofing the source address. Now again, this is a very simple activity. Here is a server. This server, we are going to stick with the fact that this is cisco.com, and this is and you have got this attacker who is sitting out here. This is a bad guy. He's sending a TCP send message to that cisco.com server. Now his real address, we are just going to make something up like 198.13.10.1. I'm just picking some random address here. That is his real address. So when he makes a connection to cisco.com, if we look at those headers, we got to remember how those headers are built, right? So we have our application data, whatever it is. In this case, we are not sending any app data. Recall in our end-to-end or our host-to-host flow section and screencast that can be find out in TCP/IP protocol stacks playlist. We talk about how the application says, hey TCP, I need a complete connection setup so that I can send some data. And then TCP says, okay, I got to do a three-way handshake. Let's go ahead. and do this. Hey IP, please send his message over to, and then it is got the IP address of cisco.com. And then the IP layer says, okay, I will go ahead and form a packet. Hey layer 2, can you send it to layer 2? Layer 2 is going to do the ARP, find the gateway and then forward it toward the gateway in this case. Okay, so what happens here? Well, again, this guy is an attacker and he is going to spoof an address. So he has some very specific software. For example, ettercap. We use that specific software and we say, you know what my address is and I'm going to pick a fake address. Now, what kind of address could I use? Well, I could use one of the internet bogons. What is a bogon prefix? Well, a bogon prefix is a route that shouldn't appear out on the internet's routing table. So bogons are kind of defined as these Martian addresses. They are addresses that would be defined in RFC 1980, 18, RFC 5735, RFC 6598. They are blocks of addresses that are not allocated to a registry and that should not be seen. So for example, let's say that we choose the bogon address of 192.88.99.5. Okay, this block of address space is actually allocated to the 624 relay anycos address that is found in RFC 3068. So that is not what we are using it for, but we are going to say that this is the source address for a TCP send. So as we pass that traffic down the protocol stack, this bad attacker that is using an application like ettercap is going to craft the packet so that the source IP is this bogon or this unused, unallocated, supposed to be seen address. Now the destination IP is that packet is going to be the IP address of cisco.com and we are going to send that packet on its way. Okay, so now this is DOS attack, right? Denial of service. So how are we denying service? Okay, well, the cisco.com service received that request, so boom, it comes across, he sees it, he says, okay, I'm going to formulate a send ACK, and he sends a send ACK. Well, that took some resources and now I'm waiting for an ACK to finish that three-way handshake. But now this attacker, who is bad, he does this several times. He keeps sending the TCP send, and maybe he is using that same source IP address. Maybe he is using the next address 67 and .8 and .9, but they are all coming from the same guy. Okay, so if that is the case, this is the denial of service and eventually the server is going to run out of resources. His CPU is going to max out because he is trying to handle these requests, and also he is not going to have enough resources to actually open up another port slot to handle the request. So again, this is a bad situation. This is just one example of a denial of service attack where spoofing is involved. Now let's take that a step further with another IP vulnerability that is on a larger scale. Now this would be a distributed denial of service attack. This has all the characteristics of that DOS attack, only rather than having that single attacker going against that Cisco server or that whatever server it is, we have many attackers and they are all over the globe. And in a coordinated effort, they launch an attack at the same time against that server. See, this gets us into botnet type activity, where somebody is using a command and control to talk to each one of these machines and initiate that attack at the same time. But the fact that it is distributed across the internet make it very difficult for that server or the network that server is on to block the denial of service attack, because it is not coming through one provider. It is not coming down one path. It is coming from multiple locations. Again, just another example of an attack that we see at layer 3. Now another example of an IP layer attack is Smurf attack, and this is really distributed denial of service attack. It just has a very specific name, Smurf attack. And this attack uses a large number of ICMP packets with the victim's spoof source IP address. And what it does is we broadcast that onto the network. We send it to a broadcast address, trying to get a bunch of reply back to this spoof address. Can you see how this attack is using multiple vectors? It is using address spoofing. It is using distributed denial of service. You see? So let's take a look at what kind of play out. So we have a device on the network that is just minding his own business, and his address is 10.1.1.1, and then we have multiple devices on the network that are going to send out this Smurf attack. And so what they are doing, they are going to send a directed broadcast. They are going to send a message with the destination IP address of 10.1.1.255. that is a directed broadcast address for the 10.1.1.1 network. Now the source is going to be spoofed by each of these machines, and it is going to be 10.1.1.1. So any other machine that sees this, all the machines in the network that see this, they are all going to reply back to that one device and utilize all of his resources. Again, an attack that is designed to cripple a machine using the header of IP, Internet Protocol. All of these at some point can result in resource exhaustion. And there are specific resource exhaustion attack, but this gives you an idea of how we have number of attacks that are going to target the Internet Protocol layer. So I will finish until here. Please subscribe our channel for more interesting tutorials and video. Thank you for subscription.